Good morning, my dear students. Welcome back to our physics class. Okay, so in the last class we have completed our second chapter, Human Eye and the Colorful World, right? Okay, so now we are going to discuss a fresh lesson. We are going to study the third chapter, that is electricity. Okay, so we are going to study about electricity. So you know, electricity is an inevitable part of our day-to-day life, right? It has an important role in our modern society, and it is a controllable and convenient form of energy for variety of uses in homes, schools, hospitals, industries and so on, right? And you know, so many equipments that electric motors or TV, generators and what? The fans, AC, fridge and so on, right? All these electrical appliances works on the help of this electricity. Even though our mobile phones also need the help of electric current, right? To charge our phones we have to use electricity, right? Okay, so electricity has a major role in our day-to-day life. Even if we have a power cut at our homes for half an hour or 1 hour, it is impossible to or it is difficult to live without light or fan for just that half an hour. After that half an hour the current will come, right? But we are not ready to, or we face more difficulties in that time, right? We cannot live without light or fan, like what we can say, we cannot live without electricity. Okay, so that much role it plays in our day-to-day life. Okay, so now we will talk about what constitutes electricity, or what is electricity. Yeah, electricity is nothing but it is the rate of flow of charge. That means the flow of charge per unit time. That is our electricity. Okay, so electricity or electric current. Electric current, generally it is denoted by the letter I. I is electric current or electricity. So it is nothing but the flow of charge per unit time. Okay, so charge, you know what is how we can represent charge? Yeah, it is represented by the letter Q. That is flow of charge per unit time, or we can say rate of flow of charge is electric current. Okay, so this is the equation for electric current. Actually the rate of flow of charge we have to represent like this, that is dq by dt. So but these differential terms you may not be familiar with these differentials, right? Actually rate of flow of charge we have to represent like this. These differentials you will study in your higher classes. It is purely mathematics differentials. Okay, so you will study about this more in your higher classes. Okay, so leave that, you just understand what I is equal to Q by T. That is electric current is the rate of flow of charge. Okay, rate of flow, you know, rate of something that we relate with time. Okay, so I is equal to Q by T. And just go through your textbook. Yeah, electric current and circuit. We are familiar with air current and water current. You know, we have to make the electric current is get from air current or water current, right? So power stations, you know, water power stations or windmills, and also thermal power stations, these all generate electricity, right? Okay, so you know, you are familiar with electric current and air current and water current, and we know that flowing water constitute water current in reverse. Okay, and similarly if the electric charge flows through a conductor, you know what is conductors? Conductors are those substances which allow the charge to flow through them, right? Okay, so conductors, most of the metals are conductors. They conduct electricity, also they can conduct heat, like that things. Okay, they can conduct or they allow the charges to flow through them. Okay, so that substances are known as conductors. So if the electric charge flows through a conductor, for example through a metallic wire, we say that there is an electric current in the conductor. Okay, so that is the electric current is the flow of charges. In a torch, we know that the cell or a battery, when placed in proper order, provide flow of charges or an electric current through the torch bulb to glow, right? So ഒരു ടോർച്ചിൽ നിങ്ങൾക്കറിയാം ബാറ്ററി ഉണ്ടാവും, സെൽ ഉണ്ടാവും. സെൽ a group of cell is then converted into batteries, right? Batteries il ഒരു group of cells ആയിരിക്കും. So there has a positive terminal and negative terminal, right? So now you have to know what the direction of current. Direction of current, we can have two directions actually. Okay, so which are they? Yeah, there is a positive terminal and negative terminal. For a battery or cell, that there is a positive terminal and a negative terminal. There should be a positive and negative terminals. So actually the flow of charge means the flow of electrons, right? So flow of electrons means electrons have a negative charge. Electrons have negative charge. So flow of electrons means these negative flows to the positive terminal, right? Okay, so the flow of charges from negative terminal to positive terminal, that is the flow of electrons, that constitute electronic current, right? That is negative terminal to positive, that constitute electronic current. This is electronic current. Okay, electronic current. And one more thing, there is another direction, that is positive to negative. How it happens? Actually conventional current flow is reverse in this order, reverse of this order. That means conventional current flow is from positive terminal to negative terminal. This is conventional current. So what is meant by conventional current? Conventional current is nothing but the current, that is everywhere we use conventional current, right? That is now current, the conventional current, so everywhere we use electricity, there we use conventional current. Okay, so we meant that conventional current flowing from the battery to, that is conventional current flowing from positive terminal to negative terminal. So in batteries and wherever we use this electricity, all that time we use conventional current. That is normal purpose il nammal use cheyyunnathu conventional current aanu. Okay, so the electric appliances all uses conventional current. So what is the direction of current? Yeah, it is positive to negative. That is in a battery the current flows from its positive terminal to negative terminal. Okay, so that is the direction of current. Okay, now again go through your textbooks. That is, we have also seen that the torch gives light only when its switch is on. So what does a switch do? So torch does not light it by its own, right? It will not glow the bulb by its own. We have to switch on the torch, right? And also the bulbs are lightened when we on our switches, right? So what these switches do? That is, a switch makes conducting link between the cell and the bulb, right? So a switch make the conducting link between the switch and the bulb, right? A continuous and closed path of electric current is an electric circuit. So what is mean by electric circuit? Electric circuit, you have an electric circuit given in the page number 200, figure 12.1. Okay, so we can just draw an electric circuit here. From that you can get the idea of what electric circuit. Electric circuit, what are electric circuit? The continuous and closed path of an electric current is called an electric circuit. So it is a continuous path. Okay, continuous and closed path of electric current. So we can just draw a circuit diagram here. So a circuit diagram constitutes a cell or a battery. Okay, so this is a cell, and you know the lengthy part represent what? The lengthy part represent positive terminal. Okay, so this is a positive terminal, and you know this small portion constitute negative terminal. Okay, so this is a cell. Okay, so this is a cell. If we draw like this, it is a cell, right? But here we have 1, 2, 3 cells. So it is actually a battery, right? It is actually a battery. Okay, so one or more cell, 2 or more cells constitute a battery. Okay, so here positive terminal and negative terminal of battery, it is connected to a metallic wire, and there is a bulb. These symbols, we have to study all these symbols later. Okay, so you just understand this is a bulb. Okay, and there should be a ammeter. Ammeter is the instrument that measures the electric current. Okay, and we have a switch. It is represented, in some cases it is represented like this. This is an open circuit. When it is like this means this touches, these two wires touches together. That means this is a closed circuit, right? If it is like this is an open circuit. And also that is, this is a switch, the representation of switch. And also we can represent switch like this. This is switch that is not, that is an open switch or on. This is on position, right? If it is like this, a dot is in between these two brackets, then it is off position, right? That is, the circuit is closed, the switch is closed. Okay, so here we have, now the circuit is open, the switch is now on. Then this is a closed circuit, right? Okay, so this is the on position. Okay, so that is, this is a closed circuit, right? So electric circuit constitutes of a battery, bulb, ammeter and a switch, right? Okay, so again go to the previous page. So a switch makes conducting link between what? These two wires, right? Okay, and a continuous and closed path of an electric current is called electric circuit. Now we draw an electric circuit. Now if the circuit is broken anywhere or the switch of the torch is turned off, the current stops flowing and the bulb does not glow. That means now the circuit is closed. Here the bulb will glow, right? So this is a closed circuit. That means current is flowing through this direction. Okay, flowing through this direction. That means here we have conventional current, right? That is positive terminal to negative terminal. Okay, this is a conventional current flow. Positive terminal to negative terminal. So now the bulb glows, right? So when the switch is like this, that means now the circuit is broken, right? Now the circuit is broken. That means this is an open circuit. Okay, so open circuit, then what happens? There will not be any current flow. Current is cut from here, right? So this is not a closed circuit. The current will not flow through this circuit. Okay, so now the bulb will not glow. Okay, so that is the role of switch. Okay, now the circuit is broken anywhere or the switch is turned off. This is off position, right? This is off position. Sorry, here I written wrongly. This is off position. Off position means the current will not flow through the circuit. This is on position. Here what happens? The current will flow through the circuit. That means the circuit will become a closed circuit. Okay. So that is the current when the circuit is broken anywhere, the current stops flowing and the bulb does not glow. That is understood, right? So how do we express electric current? Now we know what is electric current. It is a flow of charge. And how do we measure this electric current, or how do we express this electric current? Electric current is expressed by the amount of charge flowing through a particular area in unit time that we have already expressed, that is I is equal to Q by T. Okay. And electric current is expressed the amount of charge flowing through a particular area in unit time. In other words, it is the rate of flow of charges. However, electrons were not known at the time when the phenomenon of electricity was first observed. So electric current was considered to be the flow of positive charges, and the direction of flow of positive charges was taken to be the direction of electric current, right? So conventional current, that is flow of charge from positive terminal to negative terminal. So at the time of when the electric current is discovered, when the electric current discovered, that time electrons are not known, right? Actually the charged particles, electrons, the flow of electrons will make current, right? But when this electric current discovered, that time electrons are not well known. Okay, so they take the direction of current from positive terminal to negative, positive to negative, right? So that is our conventional current. Everywhere we use current, that we use conventional current, right? Okay, but there is also electronic current that have a direction from negative terminal to positive terminal. That is, nowadays we know electrons were discovered, and after that electronic current again come to know, right? Electrons കണ്ടുപിടിച്ചതിന് ശേഷം electronic current വന്നു. Conventional current എന്ന് കണ്ടുപിടിച്ചോ അന്ന് മുതൽ യൂസ് ചെയ്യുന്നത് പോസിറ്റീവ് ടു നെഗറ്റീവ് ആണ് ചാർജസിൻ്റെ ഫ്ലോ. സോ ദാറ്റ് ഈസ് കൺവെൻഷണൽ കറണ്ട്. സോ at the time when electrons are discovered, then there comes electronic current also. That means the current flowing or the electrons flowing from negative to positive, right? So that is electronic current. Here the flow of electrons that constitute electricity. Okay, that is electronic current. And conventional current, we know the flow of charges from positive terminal to negative terminal. So conventionally in an electric circuit, the direction of electric current is taken as positive to the direction of the flow, as opposite to the direction of flow of electrons which are negative charges, that we have already discussed. That means electronic current is in the direction of negative to positive. So our conventional current is opposite to that. Okay, so that is said in your textbooks. If a net charge Q flows across any cross sectional of cross section of conductor in time t, then the current I through the cross section is I is equal to q by t. So that is the flow of charge per unit time. Okay. This current has a unit of what? Coulomb. The SI unit of current is, the SI unit of current is Coulomb. Coulomb has a spelling, you have to note the spelling. Coulomb, C-O-U-L-O-M-B. Okay, this is Coulomb, right? And it is also written as C. So the SI unit of current is Coulomb. Okay, so which is equivalent to the charge obtained or charge contained in nearly 6 into 10 raised to 18 electrons. We know that electrons possess a negative charge of 1.6 into 10 raised to minus 90 coulomb. Okay, so electron has a charge of what? 1.6 into 10 raised to minus 90 coulomb. So 1 coulomb is equal to what? 6 into 10 raised to 18 electrons. Okay. And the electric current is expressed by the unit called ampere. So now charge has a unit of coulomb. So what will be the unit of current? Electric current has a unit of ampere. Okay, ampere. It is also written as A. Okay, so the SI unit of electric current is ampere. This is named after French scientist André Marie Ampere. And now we can define 1 ampere. So define 1 ampere. What is ampere? Ampere is the unit of electric current. So from here we can define 1 ampere. What is 1 ampere? 1 ampere is constituted by the flow of 1 coulomb of charge per second. That means 1 coulomb of charge per second. 1 ampere is equal to 1 q by 1 t. That means 1 coulomb of q, the unit of q is coulomb. Unit of charge is coulomb. So 1 ampere is the flow of 1 coulomb of charges per unit time. Okay. So that is 1 ampere is defined as the current when a number of electrons having 1 coulomb of charge move past in a given point in 1 second. Okay. Here time has a what? Unit of second. So this is 1 ampere. That is 1 coulomb of charge flowing through a cross sectional area of in a time of 1 second, right? Okay, so 1 ampere, you should underline 1 ampere is constituted by the flow of 1 coulomb of charge per second. Okay, and that is 1 ampere is equal to 1 coulomb divided by 1 second. Small quantities of current are expressed in microamperes also. So now we know the SI unit, actually the SI unit of current, electric current is ampere. So small units of electric currents can be expressed in the unit of microampere. Okay. So microampere, milliampere, like that things. And 1 milliampere, you know, 1 milliliter is equal to how many liters? Yeah, 10 raised to minus 3, right? Okay, that like that we have milliamperes, microamperes. So 1 milliampere is equal to 10 raised to minus 3 amperes. And also 1 microampere is equal to, micro means, you know, micrometers, or micro is a smaller unit, right? So 1 microampere is equal to 10 raised to minus 6 ampere. Okay. So 1 microsecond, you know what is 1 microsecond? Microsecond means that much smaller time, right? So 10 raised to 6 represent micro and 10 raised to 3 represent milli, right? Okay, so 1 milliampere is equal to 10 raised to minus 3 ampere and 1 microampere is equal to 10 raised to minus 6 ampere. Okay, so these are the smaller units of electric current. And an instrument called ammeter measures the electric current in a circuit. So now we have this is ammeter, right? This measures the electric current flows through the circuit. So we have to note that how much electric current flowing through this circuit, right? So that reading is given by this ammeter. Okay, so this is ammeter. Okay, so ammeter is double M. Ammeter, double M. Okay, so ammeter is what is ammeter? It is an instrument that measures electric current in a circuit. Okay, so it always connect in a series. It is always connected in series in a circuit through which the current is to be measured, right? So it is in the coming classes you will study what is series connection and parallel connection, that all things you may study. Okay, so now you just understood what this is a series, right? From here to here, this is a series. So ammeter is connected in series with this these all things, bulb, ammeter, switch and is cells. Okay, so the connection between this bulb and ammeter is in series mode. Okay, and another mode of connection between is there, that is parallel connection. That is parallel, you know, these are parallel lines. Okay, so here we have a switch and here we have an ammeter. Then we can say that these two are connected in parallel ways, right? That all things we will study in the coming classes, right? Now you just understood what it always, that is ammeter is always connected in a series in a circuit through which the current is to be measured. Okay, so this is, in this way we measure current, right? From here to here to here, here and here. So current is measured in this direction. Okay, so ammeter is also connected in series with this circuit. And an electric bulb and ammeter, also we have a plug, that is here we have key. All these things constitute an electric circuit. Okay, so that is given in your textbooks, page number 200, figure 12.1. Note that the electric current flows in a circuit from positive terminal of the cell to negative terminal of the cell through the bulb and of the cell through the bulb and ammeter. That means electric current flow, we know conventional current, that is electric current flows from positive terminal to negative terminal of the cell through the bulb and ammeter. So here we have positive terminal of cell and then we have bulb and then we have ammeter, then key, then we have negative terminal. Okay, so when the key is closed, that means this is the switch on position, right? Now the circuit is closed and the current is flowing through this circuit and the bulb will glow. Okay, so this is a schematic representation of an electric circuit, that is a closed electric circuit. Okay, that is about today's class. Okay, so you have an example given, a current of 0.5 ampere is drawn by a filament of an electric bulb for 10 minutes. Find the amount of electric charge that flows through the circuit. So what is the question? A current of 0.5 ampere, that means we know I is given, right? We have the electric current I is equal to Q by T, right? And it is given that current is equal to 0.5 ampere, okay? That is 0.5 ampere is given, 0.5 ampere is given I, okay? And what is the question? 0.5 ampere is drawn by a filament of electric bulb for 10 minutes. That means T is also given. That is T is equal to 10 minutes. So 10 minutes equal to 10 into 60 seconds. That means 600 seconds. Okay. And then what is the question? Find the amount of electric charge that flows through the circuit. So here the circuit I wipe. That means we have a circuit, we have a closed circuit, and the current flowing through that circuit is having a value of 0.5 ampere and within a time of 600 seconds. So now we have to calculate Q. What is Q? I is equal to Q by T. Then we have Q is equal to what? I by T, right? That means 0.5 divided by 600. So what will be the answer? Sorry, Q is equal to what? We have to cross multiply this, right? So Q is equal to IT. That means here I by 1 is equal to Q by T. So by cross multiplying this we get what? Q is equal to IT. So what is Q? I we have 0.5 and T we have 600 seconds. So what will be the answer? It is 300. So what is the unit of this Q? 300 coulomb, right? This is the SI unit of charge. So we get 300 coulomb of charges flown through the circuit, flows through the circuit to what? Constitute a current of 0.5 ampere. Okay, so that is the question. And you have some more questions in the box. 1, 2, 3 question. What does an electric circuit mean? And define the unit of current and calculate the number of electron constituting 1 coulomb of charge. So these all questions you should do as homework. Okay, so this is compulsory. You should do the homework. Okay, and send to me the next day. Okay, so now we are going to wind up, and today we studied about what is electric current. Electric current is the rate of flow of charge per unit time, right? That is flow of charges per unit time. That is electric current. And what is the unit of electric current? Electric current having a unit of ampere, and the smaller units are milliampere, microampere, like that. And it is equal to I is equal to Q by T. That is flow of charge per time, per unit time. And what is another things we learned today? That all things. What is circuit? A closed circuit endana circuit ne close cheyuna main thing ennu parayunnathu switch aanu. Okay, switch closed aayirikkumbo switch off പൊസിഷൻ ആണെന്നുണ്ടെങ്കിൽ അതിലൂടെ കറണ്ട് പാസ് ചെയ്യില്ല. സ്വിച്ച് ഓൺ പൊസിഷൻ ആണെന്നുണ്ടെങ്കിൽ സർക്യൂട്ടിലൂടെ കറണ്ട് പാസ് ചെയ്യും. ഓക്കെ, സോ സ്വിച്ച് ഈസ് ദ മെയിൻ തിങ് ദാറ്റ് മേക്സ് എ ക്ലോസ്ഡ് സർക്യൂട്ട് ആൻഡ് ആൻ ഓപ്പൺ സർക്യൂട്ട്, റൈറ്റ്? ഓക്കെ, so that are things we discussed in this class. Okay, so the next class we have to discuss electric potential and potential difference, and that things we have to discuss. Okay, so we can meet in the next class. If you have any doubts you can ask me. Okay, and one more thing, you should do these problems, question 1, 2, 3, page number 200 as homework. Okay, so okay children, we can meet in the next class. Thank you.